Hello everybody, welcome to part 11 of Senior Developer in 24 Hours. Today we're going to continue our conversation regarding unit testing, and we're going to talk about some more advanced techniques and mechanisms that we can use to have better unit testing. My name is Andres, and thanks everybody for tuning in. Hopefully you'll find this useful. All right, so after this video, we should have a better understanding of how we can use advanced features from our frameworks, for example, parameterized tests, to cut down on boilerplate code and have higher quality tests, tests that are easier to understand, tests that are easier to maintain, tests that are going to give us more confidence in the code that we are writing. We're also going to identify some cases where we end up with really hard to test code. And of course, we're going to talk about some of the options that we have to deal with this hard to test code. But before we get started, let's have a quick recap of why are we even doing this in the first place. Everybody talks about, hey, unit tests are important. Sure, they are. But why are they actually important? They're vital to us because they help us uncover bugs. That's the most obvious benefit that we get from using unit tests. They also make maintenance easier because, we have something that will double check our work. They increase the trust in the code base. And probably the most important thing is it makes developers more effective because they can make changes quicker and with less risk. Now, having said that, let's talk about how we can leverage the framework to be able to, churn out large numbers of unit tests that are easy to maintain, easier to understand. And the first technique we're going to take a look at, it's called parameterized tests. And, whenever we're writing code, especially when we're writing things that has a lot of rules, things like that, a relatively small piece of code is going to require a lot of different test cases. And those test cases can get repetitive pretty quickly. And obviously, when we have a lot of copy paste, when we have a lot of duplicated code, it makes maintenance much more complicated. And remember, we want to keep our test as simple as possible, as easier to understand. We want to avoid having, crazy looping, crazy branching, things like that, so that if somebody comes in and tries to understand what a test is doing, it is very evident. All right, so what we want to do, we want to leverage our framework to write smarter tests. Parameterized tests enable us to execute a single test method multiple times with different parameters. How does this look like? Traditionally, when we have some code, we'll write a little test that looks like this. In this particular case, we have an account object. This is going to keep track of our balance. This is going to keep track of our transactions. And, we start with the basic paradigm that we were talking about yesterday, given that we have a new account that has 10. When we withdraw 5, then we expect to have 5 left, and we expect the transaction to have been successful. And that's great. But, then we have to start testing other cases. So, we end up with another test case for testing insufficient funds. And if you see here, it's basically the same test. We just have slightly different inputs and obviously different outputs. And as you can imagine, this can get really unmanageable pretty quick. So, for example, framework like Jest, which is the one that we're using this for this small JavaScript example, allows us to specify a list of parameters that we can use to execute the same method multiple times, passing different inputs and passing different assertions that we're going to check for. So here we have an array of arrays. Each of the arrays is the parameters that we're going to pass to each iteration of the test. So for example, in the first array, we have 10, 5, 5, and true. We're starting with 10. We're going to withdraw 5. We're going to be left with 5, and the transaction is successful. Then we have another case. Again, we start with 10. This time we try to withdraw 15. The balance is going to remain the same, but the transaction is going to be denied. So we have all of the setup. We have, when we're acting on our actual code, we have the checks, the stuff that we are asserting on, and then we're plugging different values. So as new cases come about, as we discover that we need to test more edge cases, as we discover bugs, things like that, we can very easily keep adding more arrays to this particular method and have more coverage, have better testing without having to add more boilerplate code. And the same mechanism is available in a lot of other languages. For example, this is an equivalent test written in Java using JUnit 5, and we have basically the same setup. The difference here is that in this particular case, we have a method that is going to provide the source data for us. But other than that, again, we are returning a stream of arguments. Each argument is a series of values, and each one of those is going to be one invocation for our test. So we have the same setup, we are following the same flow, and we can add a lot of parameters. We can add a lot of different cases to get more comprehensive tests without writing a lot of extra code. Of course, this code is a little bit more verbose than the JavaScript one, because Java is more verbose, for better or worse. All right. Having said that, let's talk about some of the more complicated cases. The first thing we want to keep track of is that we want to limit the code that is hard to test. We want to have very high coverage of our test. We want to cover as much of the code as we can. There's always, some little pieces that might not be easy to test, but we want to limit them as much as possible. With that said, most of the code that we have, most of the code that we write tends to be deterministic. Given a particular set of inputs, it will always produce the same output. However, in practice, obviously, there are a lot of things that will cause us to have non-deterministic code. The most typical one is when we depend on external systems. We depend on an external web service. We depend on an external database. We depend on an external system for which we might not have full control. A lot of times, we might not be the only ones using that system. There might be other developers using the same system, so they might go in, they might change the data, they might add more data, things like that. So in that case, if we are writing unit tests that talk to some of these external systems, our test code becomes, non-deterministic. Sometimes it will work, sometimes it will fail. And that is extremely problematic because we have to spend a lot of time figuring out what changed, figuring out how we can get it into the right spot, how we're going to prevent this from happening in the future. So the obvious solution is that we mock away the external system. And on the next video, we're going to talk a lot about specific mechanisms that we can use to extract this system and have it behave in a way in which we can fully control it, and it's going to be a lot easier for us to create this really deterministic code, even when we are dealing with external services that in production we might not have full control over. But even within our own code, when we exclude any external services, just the code that we write, there are some exceptions that could make our code non-deterministic. And the two main ones are the random number generation. when we call a method like math.random, we're definitely getting something non-deterministic. Depends on the seed that the random number generator was started with. So, it becomes a lot more non-deterministic. Another one that sometimes might get you is getting the current time. Obviously, getting the current time depends on when you're running the test. And well, sometimes the output of these functions are important for our code. For example, if we are trying to verify that we're calculating the right expiration time for a token that we're creating. Or for example, we need to verify that some algorithm that we wrote that uses some random seed is correct. So, in those cases, we have to worry, hey, how are we going to deal with the fact that our code is depending on some code that is not deterministic? And how are we work around those things? Of course, there are other cases where the output of these functions is not really important to our code. For example, if we just need a random ID to identify a transaction, probably any value is going to be fine. We don't have to worry too much about that. If we're just getting the current date and time for informational purposes, probably we don't care too much about that. So, if the output of these functions is really important for us, what do we do? The first option is considering refactoring away so that we can mock it somewhat easier. So let's look at something like this. Here we are creating a new token. We're creating a new token that is going to expire in 5 minutes from right now. And, we're going to create this token for a particular user. This is pretty simple, but again, we have something that is non-deterministic. How are we going to verify that the right expiration date was created? There's always going to be a delay between the time that we create the token and the time when we can actually assert that the value is right. So we could try to add a range. We could try to add, something to verify that at least it looks like a valid expiration date. But there's something that is going to help us make our code a lot more deterministic. And that is basically extracting away this non-deterministic code into a very simple wrapper. Again, this wrapper is doing pretty much nothing other than calling local datetime.now. But now what we have here is something that is very easy for us to mock in our test code. Obviously it's adding a little bit of complexity. It is adding an extra class. It is adding an extra object that we're going to have to wire into our code. But by doing something like this, it makes our code significantly more testable. There is another type of code that is a lot harder to test, and that is static code. So static code is basically a block of code that is executed whenever the code unit is loaded into memory or from disk. And normally it's basically any code that is marked as static in Java, code that is outside of classes and functions, things like that. Normally static code is hard to test. And there are reasons why sometimes, we have to use static code. Sometimes it's a performance issue. We don't want to deal with the overhead of using some kind of dependency injection, things like that. So as much as possible, we want to avoid it, but sometimes we have to deal with it. And what does it look like? Something, for example, here, we have a class called basic in this small Python example. If you see here, we are checking the name of the operating system that we're operating. And if it's not a POSIX operating system, we are going to raise an exception. Whenever this class is loaded, we are going to execute that little block of code even before we instantiate an object from this class. In Java, it is a little bit more explicit when we are dealing with static code because we have the static keyword. So pretty easy to understand when we have this type of code. All right, so what options do we have for dealing with static code? The first one is to encapsulate the static code. Once we encapsulate it, we can have a unit test that can call this encapsulated code if appropriate. And then we can have a static call to the newly encapsulated code. If possible, sometimes there are cases where it is not even possible to do this. That's why we have to find the right balance between how much we want to test. Obviously, we want to keep a high enough coverage, but realistically, trying to achieve 100% coverage is normally not viable. And things like this, these static calls tend to be some of the areas where we might have a challenge to be able to fully test. Now, having said that, what if my code, overall, is too hard to test? Well, if your code is too hard to test, it might be a very clear indication that the design might be wrong. Sometimes our code is hard to test because we also rely on third-party libraries that make testing hard. For example, we might rely on third-party libraries that lack dependency injection and instead rely on environment variables, things like that for configuration that make, elegant unit testing more complicated. Maybe these third-party tools use static initializers and methods, so we have very little control of when those get executed. Sometimes they have things like private methods or final classes that we cannot mock easily. Luckily, there are some tools that allows us to work around these issues. For example, if you're in the Java world, PowerMock is a fairly popular tool that allows us to do things like test, to create mocks of final classes, things like that. PowerMock basically hooks into the class loader and can modify classes as they're being loaded. Sometimes we can use the library in a different way whenever we are writing our test. For example, if we're using gRPC is notoriously complicated to test because most of the classes that it generates are final, so we cannot mock them. But on the plus side, it provides a very, somewhat user-friendly in-process server that we can use to mock the behavior of the gRPC server within their own framework. Some interpreted languages, such as Python and Node, allow us to do manual monkey patching, which basically allows us to switch over different methods within a single class, things like that. However, all of these exceptions come with some significant drawbacks, so we have to be very careful when we're using them. PowerMock is a tool that shouldn't be used unless there's a very good reason. We want to avoid overuse of this because it can potentially hide design issues that we want to prevent. The same thing with, manual monkey patching. If you patch something enough, you might end up testing something that is not even close to what it's going to be running in production. So again, one of the roles of a senior developer is to make those judgment calls and on a case-by-case basis, have input on whether we should be using some of this advanced tooling that could have negative side effects. All right, now let's talk about some tips for unit testing, concurrency, and multi-threading. And overall, just don't try to test this. As much as possible, try to switch over to immutable objects, reduce the number of places where multiple threads interact with the same instance of an object. And at the end of the day, you have to understand that any unit test that you do on multi-threading and concurrency is going to be quite limited, or it's going to be extremely onerous. It's going to be extremely brittle when you're dealing with multiple threads that have to coalesce, things like that. It makes it a lot more complicated. So overall, as much as possible, try to defer to integration testing. Again, after you clean it up as much as possible to reduce concurrency and multi-threading potential pain points, defer to integration testing. That's where, you can start scaling up, adding more load, things like that, to ensure that we are covering those cases. Also, you can consider some static analysis tools that will examine your code and try to identify potential multi-threading and concurrency issues. Because, again, we should be testing this code. We should be testing that the code works. But normally, as much as possible, we try to run unit tests in a single thread. So, static analysis might give you an extra pair of eyes to identify potential issues that otherwise you might spend hours and hours creating super complicated unit tests to be able to uncover these kinds of issues. All right. So with that said, wrapping this up, it is very important that we really think how we're going to test the code as we are writing the code, as we are designing the code. Remember, eventually somebody's going to have to write that unit test. Let's make it easier for that person. That person is normally ourselves, but again, let's make it as easy as possible. Don't be afraid to change the design to make it easier to test. Sometimes, you might end up with a design that might look a little bit weird, but if it's easy to test, at least in my personal opinion, that is a solid design. Keep the test simple but meaningful. Again, leverage your tooling, leverage your unit testing framework to have elegant but meaningful tests. If you use parameterized test, it is very easy to add more cases as you find bugs, as you find, edge cases that you need to test. Take pride in those tests because for a lot of developers, they tend to be one of the entry points into your code. So if they can understand the test, they might have a better chance of understanding the code that you wrote. Finally, hey, write the test. Even if it's a simple test to start with, you can then build upon it. And if you can run a simple unit test, then as more features are added, as bugs are found, it makes it a lot easier to be able to add more onto an existing test rather than figuring out that, hey, I need to write a test, but this code is not really easy to test. So, hey, write something, commit something, make sure you have some level of coverage, and that will not only validate that the code works, at least for a particular set of inputs, but it also validates that the design that you created is a design that is easy to test. Okay, and what are we going to talk about in the next video? We're going to talk about integration testing. Integration testing is also a very broad topic. Basically, anything that is not a unit test is considered an integration testing. How much are we integrating? Are we integrating a couple of classes? Are we integrating a couple of microservices? Are we integrating a bunch of different microservices and a bunch of different external services? All of those things are considered integration testing. So there's a lot of variety here, and we're going to talk about techniques in which we can have integration testing that are useful and easy to maintain and that provide benefit to the team. With that said, thanks for watching. If you enjoyed this, don't forget to subscribe. Feel free to share this with your coworkers, with your team, with your friends. You can find me on Twitter, you can find me on Mastodon, or you can check out my webpage, www.javaprocess.com. Thank you.